Good morning, dear students. My name is Radheshyam, and we are going to discuss significant figures in this video, in this lecture. So, whenever we are experimenting to measure some physical quantity, when we are reporting the measured value, it should always reflect the precision of the instrument. This is the point, that whenever we are measuring any physical quantity, the right way would be to report the physical quantity to be so what I am saying, that whenever we are experimenting and reporting the physical quantity, when we are reporting the physical quantity, so I am saying that whenever we are reporting the experimental value, the experimental value should always be reported as the precision of the instrument. So what I meant by that let's say that our precision of the instrument is 0.001 centimeter. Let's say that we are measuring length and the precision of the instrument is 0.001 centimeter. So if we report a value, if we measure a value and we are reporting the value to be like this, 2.3045, so you know that the precision, this is the precision of the instrument. This is precision of the instrument. So you cannot measure more accurately than this. We know that, already know that whatever is the precision of the instrument, you cannot measure more accurate than that. And so if we are reporting like this, after decimal we are reporting for 4 point, or let's say that we are reporting till 6 point or 7.567, we are reporting like this much centimeter. So this shows that these values are superfluous. These value cannot be reliable. Our instrument cannot measure more than 3 decimal points. So that's why whenever we are measuring, whenever we are reporting, we always try, or the accurate way is always to report the value as the precision of the instrument. Okay, because ultimately this value does not make any sense. You cannot measure more precise than the given precision of the instrument. That's why whenever we are reporting an experimental value, we always try, or we always have to keep in mind what is the precision of the instrument. So significant figure is, now let's say that we have reported this value 2.30 because we know that we cannot go further than 3 decimal points. So we have reported this is our length. So we are saying that the significant figure is always calculated like this. So this is known reliably, this is known reliably, and this is known reliably, and this number we already know that this number cannot be reliable, because precision of the instrument, we know that whenever we are measuring the value, we always write it like this: plus minus what is the least count of the instrument. So 001 centimeter, will write it like this. So we say that this is unreliable digit, and these are reliable digit, unreliable digit and reliable digit. So significant figure is total number of reliable digit. We are very sure about those digits. Reliable digit plus first plus one of the unreliable digit, 1 plus 1 unreliable digit. What are we saying? That significant figures always represent reliable digit plus 1 unreliable digit. We know that if the precision of the instrument is 0.001 centimeter, then this last digit is unreliable because there is chance of error, and that's why significant figure in this case will be, significant figure for this 2.304 will be 4. We just count the number. This is reliable, this is reliable, this is reliable, and this is unreliable. So 3 reliable plus 1 unreliable digit, and that's why the significant figure for this number is 4. Similarly, you can say, let's say that it's given 5.53.206. this is the number given, and we want to know what is the significant figure of this. So we'll count this number: 1 2 3 4 5. So significant figure for this number will be 5. So in this way we decide what is the significant figure of any given number. So there are some rules, because there comes some doubt, and because of that there are some rules that we have to follow, and we'll see how we follow the rules. So let's say that we are given an example of that we are given 2.304 centimeter. Let's say that we are given 2.304 centimeters. So if somebody asks what is the significant figures, we'll count the numbers and we'll say that this has 4 significant figures. But if somebody changes its unit, let's say that somebody changes its unit, and now we are reporting it like this 23.04 millimeter. Okay, so what will be the significant figure of this? This will have significant figure 4. So the rule is that this is the common sense, that change of unit must not change significant figure. Change of unit does not change significant figure. So if this was given centimeter and we have changed it to in millimeter, so its significant figures will remain same. So now let's say that if we have changed its, again somebody changed its unit to be in meter, so this will become 0.02304. okay, this is meter, and somebody changes its unit also. So now let's say that its unit have been changed to kilometer, so we'll write this like 0.0002304 kilometer. So this is the basic thing, that change of unit does not change significant figure. So the rules of the significant figure is that all non-zeros quantities are significant. All non-zero digits are significant. All non-zero digits are significant. So we will if any given number it is asked what is the significant figure, then we know that all non-zero, these are significant. 2, 3 and 4, these are significant. You do not have any doubt in that. And zeros between non-zero digits are significant. Zeros between non-zero digits are significant. So this zero is also significant. So rules are that all non-zero digits are significant, and zero between non-zero digits are also significant. We say that the concept is simple, that change of unit does not change significant figure. So there will be no doubt about this, that all non-zero digits are significant and zeros between non-zero digits are significant. There is no doubt about this. So in this case, now let's say in this case, how do we calculate about leading zero? This is called leading zero. So this will be leading zero. This is leading zero. So the third rule is that if a number is less than 1, if a number is less than 1, then we say that leading zero left of first non-zero digit, left of first non-zero digit, and right of decimal point are not significant. So what are we saying? In case of leading zero, these are called leading zero. This is leading zero. So in case of leading zero, we say that if number is less than 1, then left of first non-zero digit. This is first non-zero digit. This is first non-zero digit. This is first non-zero digit. So we say that left of first non-zero digit and right of this decimal point. This is decimal point. So right of decimal point, left of first non-zero digit. So this zero is not significant. These zeros are not significant. So what is the rule for leading zero? What is the rule for leading zero? Leading zero is that left of first non-zero digit and right of decimal points are not significant. So these zeros are not significant, and so thus still we have 4 significant figure. Rule is same, that change of unit cannot change. Change of unit must not change the significant figure, and that's why leading zero. In case of leading zero, when the number is less than 1, so the zero from first non-zero digit, left of first non-zero digit and right of decimal points are not significant. So hopefully this is clear. And then let's say that we are still talking about those. So the next condition is, now let's say that somebody change its dimension again, and we have converted it to micrometer. So 2.304 and 0. So this is micrometer, this will be micrometer. So in this case also we need to have 4 significant figure. So it's not like change of unit should change significant figures. So there is this is called trailing 0. This is trailing 0. This 0 is called trailing 0. So in case of, so now we have rule for trailing 0, we have rule for leading 0, we have got the rule for leading 0. And now the rule is for trailing 0 is that if there is no decimal, or let's say that if the given number is greater than 1, if number is greater than 1 and there is no decimal, there is no decimal point, then trailing 0 are not significant. Then trailing zeros are not significant. But if there is a decimal point, now let's say that we have a case like this, 3.600, and let's say that this is centimeter and this is changed to, again changing unit must not change the significant figure. So this has 4 significant figure. So let's say that we have changed its unit to 36.0 millimeter. This has 4 significant figure. So the 5th rule is, if number has decimal point anywhere, then all trailing zeros are significant. Zeros are significant. If number has decimal point anywhere, then all trailing zeros are significant. It doesn't matter whether the number is greater than 1 or less than 1. Change of unit does not change significant figures. Okay, so hopefully there is no doubt about this. So we say that to remove this confusion about trailing zeros, what we do, we express the number in terms of exponent.